Hello, today we'll be looking into the process of drawing the Bohr-Rutherford diagrams for elements. So the Bohr-Rutherford diagrams, it just tells us the process by which the electrons, they take in the energy levels around the nucleus. Now, to look into the process, the first thing we need to know is the total number of neutrons, protons, and electrons in an atom. So let us take the example of sodium. Sodium, if you look into the periodic table, its atomic number is 11 and its mass is 23. So from this given information, we are going to be calculating the number of neutrons, the protons, and the electron in this element, which is sodium. Now, the process is very simple. So to calculate the number of protons and electrons, we just need to be looking at the atomic number, which is 11. Here, the atomic number tells us that the number of protons in sodium are 11, and so are the number of electrons also. And that is the reason the positive charges and the negative charges, they cancel out one another, which makes the atom neutral. Now, to calculate the number of neutrons, we know that the mass number is equal to the number of neutrons plus the number of protons. So the neutrons can be calculated by taking the mass number, which is 23, and subtracting the number of protons from it, which are 11. And so the number of neutrons over here we get is 12. Now, there are two rules which we have to follow whenever we want to draw the Bohr-Rutherford diagram. So we know that the protons and the neutrons, they are found in an atom inside the nucleus. And the presence of the proton is what makes the nucleus positively charged. And the electrons, they revolve around the nucleus in circular orbits, which are also called as energy levels. Or orbits, or shells. So this is just an important information that the electrons, they are found around the nucleus. Now let us start drawing it. Now we need to know rule number 1, which says that the maximum number of electrons in a shell, it goes by the formula 2n square, where n is the shell number we are talking about. So let us check this out. The first shell, it will have the maximum number of electrons, which can be calculated by 2 times 1 square, which is equal to 2 electrons. So which means in any case, our first shell cannot have more than 2 electrons. The maximum number of electrons can be 2. It could be less if the element does not have enough of electrons, but it cannot go beyond 2. Now let us look into how many maximum electrons the second shell can have. So the second shell can have 2 times, instead of n, we'll put the n as 2 because we are talking about the second shell, square, and this gives us 8 electrons. Third shell, so I think you also can do it now. So the third shell will have 2 times 3 square, which is equal to 18 electrons. And we can keep going by this formula and we can calculate the maximum number of electrons which a shell or an energy level can hold. Now, this is not enough. We just have to know rule number 2 also. So according to rule number 2, the last shell, which is also called as the valence shell, it cannot have more than 8 electrons. So this is a very important rule. So when we are trying to figure out how many electrons each shell can have, we have to follow rule number 1, where we get to know how many maximum electrons each shell can hold. And on the top of it, we need to know rule number 2 also, according to which the last shell or the valence shell cannot have more than 8 electrons. So we'll keep these 2 rules in mind, and let us now try drawing the Bohr-Rutherford diagram. So we are trying to draw the Bohr-Rutherford diagram for the same element we took on the top. So sodium, we know, we said it has protons, which are 11, neutrons, which are 12, and electrons, which are again 11. So let us first draw the nucleus of this atom. So we have this small tiny nucleus, and this nucleus will have protons, which is 11, and it also has neutrons. You already know it is 12. And now let us start putting the electrons in the energy levels or shell. So let us make the first energy level. Now, how many electrons we can have in this one? So we already know that the maximum number of electrons the first shell can have is 2. So what I'm going to do is I'm putting 2 electrons in this first shell. So 1 and 2. Now, out of the 11 electrons, I have already used 2, and I'm left with 9, which I have to accommodate around the nucleus. Now, so we definitely need the second shell. We have drawn the second shell, and now we know that it can have a maximum of 8 electrons. So let us try putting those 8 electrons, because we still have 9. 1, 2, 3, 4, 5, 6, 7, 8. We have put in 8 electrons. We are still left with 1 more electron. So let us make 1 more energy level or shell. And because this is the last shell, it can have 18 electrons. So we will put that 1 single electron over here. But at the same time, we'll make sure that because this last shell, it is the outermost for sodium, it should not have more than 8, and that way we are correct. So this is the Bohr-Rutherford diagram for sodium. Now let us take another example. We will take another element. Let us take calcium. Calcium, its atomic number is 20, and its mass number is 40. So first, let us write down the electrons, the protons, and the neutrons. As we talked about it, atomic number gives us the information of the protons and the electrons. So the number of protons is the same as atomic number. The number of electrons also is the same as atomic number. And the number of neutrons could be calculated by taking the mass number and then subtracting the atomic number from it, and then we get number of neutrons also as 20. So now let us make the nucleus of calcium. So calcium, again a small tiny nucleus, it will have 20 protons, 20 neutrons, which makes the nucleus positive. Now we are trying to look for those electrons, because we have to put in these electrons in the energy levels or shell. So let us draw the first shell, and this first shell or energy level, how many electrons it can hold? We know that it can hold a maximum of 2 electrons. So we put the 2 electrons in the first shell. Now what I'm going to do is from 20, I subtract 2, and I'm still left with 18. So I have to make the second shell. And now this second shell, we again know that it can hold a maximum of 8 electrons. So let us draw the 8 electrons in it. 1, 2, 3, 4, 5, 6, 7, and 8. So from 18, we have drawn 8 more electrons in the second shell, and we are left with 10 more. Let us draw the third shell. We'll go back to check how many electrons the second shell can hold. So third shell. So the third shell can hold a maximum of 18. And we have how many? 10 more. But because if we put these 10 electrons, this is going to be the outermost shell. So we cannot put 10 electrons because if it is the last shell, it can hold only 8. So what we have to do is we need to put 8 electrons in this one and then move 2 electrons in one more shell, which is the fourth shell, and now we put in the 2 more electrons. So this is the Bohr-Rutherford diagram for calcium. So remember, the first shell can have 2 electrons, the second shell can have 8 electrons, the third shell can have 18 electrons, the fourth shell can have 32 electrons. If you just go by the same formula, right? But if a shell is an outermost shell, if the third shell, suppose, is the outermost shell, it cannot have 18, then it can have only a maximum of 8. Let us take one more example and understand it better. So let us now take the example of potassium. Potassium has a total of 19 electrons. So now we'll not be putting the electrons because you already know how to draw the electrons in the shell. We'll just try to review the rule and see how the electron configuration is going to look like. So potassium atomic number is 19 and mass number is 39. So its electrons are 19, protons are also 19, and neutrons are 39 minus 19, which is equal to 20. So these protons and neutrons, they are going to remain inside the nucleus. And for drawing these electrons now, let us go ahead. The first shell can have 2 electrons. The second shell can have 8 electrons. How many electrons did we already use? 8 plus 2, 10. So out of 19, we have already used 10. We still need to put in 9 more electrons. So the third shell can have 18. So if I put 9 electrons, we are good by rule number 1. But because we are done with the electrons, we have no more electrons. So this shell, the third shell, is the outermost shell. And according to rule number 2, we cannot have more than 8 electrons. So what we actually need to do is, we need to get rid of this 9 electrons from the third shell, and then nothing is going to happen to the electrons in the first shell. So first shell will still have 2. The second shell will have 8. The third shell will again have 8, and that 1 electron we'll have to put in the last shell. So the electron configuration is 2, 8, 8, 1 for potassium. I hope you guys understood the concepts. Bye-bye.